Slides. You're watching at slides, a continuity of pictures. What's the link, their common characteristics, between this fork and this knife, this man? Oh, this one is blurred. What's the link? The color? No. Photography? Neither. The link is beyond photography, beyond the image, beyond the object, beyond our vision. Light. But what is it? Is it the sun, the sky, the fire, the bulb, the screen? Light does not belong to objects. It's the light which gives an existence to our visual world. The light is what we see. No mug, no cow, no sky or no mayonnaise. The bulb is off. I don't see anything. No image. There is the position of our objects. I turn the light on, I see the bulb. I see the mug and the background. I see the mug only if I see the bulb. Well, only if the light is on. And only if there's nothing between the bulb and the mug. Almost. The bulb emits light, the mug receives some light, and then I see the mug. As simple as it could be, some explanations may be helpful. First, I can show you the light because it's the unique element that builds our image. How can we imagine a representation, an icon, a symbol rising from its definition? Maybe knowing the nature of the light is a good idea. I can't be exhaustive in this exercise. The subject is quite infinite. An electromagnetic field is surrounding us at any moment, created by the presence of charged particles and by their movement. The curves are a perturbation of the rope. The waves are a perturbation of the surface of the water. The light is the perturbation of an electromagnetic field. The particle of a null mass that transports this energy is the photon. Each wave has its own frequency. Thus, the light is a particular case of the whole electromagnetic waves. The gamma and beta waves produced in the heart of nuclear power stations or during stars exploding. The X-rays used in medicine are sufficiently powerful for crossing our whole human body except for bones. The ultraviolet are heavily produced by the sun. The life out of water has been possible on Earth when the ozone layer started to absorb most of them. Here comes the light, the part of the electromagnetic spectrum that our eyes are capable to analyze. Violet, blue, green, yellow, orange, red. The infrared, the warming waves, are emitted by every material like the sun or the hamster. In front of a fire, we are heated by the infrared, not by the hot air. Microwaves. Microwaves often use that particular frequency to heat up water molecules. The radio waves. Frequencies used by radio stations. The antennas put electrons in vibration, and your antenna receives the signal with its own electrons. Vibrations are then converted by a machine into a signal. All those waves are propagated at the speed of 299,792 km per second, or 1,079,251,200 km per hour. To understand that, let's enter into the material receptor of the light. Meet the atom. A proton, an electron. Let's focus on the electron. By default, the electron is in fundamental state. If it receives a photon, its energy increases and it raises an upper level of energy. But it can't stay in this state. It has to emit a photon to unleash the absorbed energy. But it's not the only way for an atom to emit light. We can also and simply heat an atom with electricity. In a bulb, electricity puts the atom in vibration, which increases its energy and then emits light. Thus, every object emits waves because atoms are constantly in movement. An object which emits no light has therefore motionless particles, and its temperature is -276.16 degrees Celsius, the absolute zero, the lowest temperature. The light is propagated this way when the crossed medium is homogeneous, like the air. When light meets another medium, the reaction depends on the material. The light can be diffused, reflected, or refracted. Let's talk about refraction. Each translucent material has its own index of refraction, and so its own way to modify the speed and the direction of the light. The light crosses glass, but a part of it is always reflected. The more the ray is parallel to the surface, the more you get some reflection, up to a total reflection. A last detail. Each frequency, therefore each color, is differently deviated. Thus we can explain the rainbow. As you may notice, rainbows appear with rain and sun. Here is our installation. We need a source of light and a waterfall. This is how it works. The light emits parallel rays. The rays reach the drops, and our point of view sees a rainbow. Why parallel rays? Because the sun is so far from Earth, we consider the rays are parallel. From a specific angle, because of the succession of refraction and reflection, the rays follow this path. If there were only one drop, we could just see one point of color, but the phenomenon is repeated on the waterfall, so we receive the whole range of colors. We see the rainbow because the water deviates the light in a certain way. The wall receives some light, absorbs a part and diffuses the rest. But we consider the wall as something real and the rainbow as an optical illusion. However, seeing the wall or the rainbow is the result of a luminous phenomenon. We see the mug. We consider the mug as at the place where we see it. If the mug moves, we follow its movement with the image we get from it. The speed of light is fast enough to see the mug where it really is. But what would happen if the speed of light wouldn't be 300,000 kilometers per second, but 1 meter per second? Where would really be the mug? What would we see when we turn on the light? Would we see the wall when the light finally reaches it? No, we would have to wait for the light to reach our eyes. So this is probably what we could see in such a world. Why did I slow down the light? To show you that even in reality, the light needs some time to reach objects. What is the present for us? It's the whole of the phenomenons which appear in one instant. This truck and this panel emit light. This light reaches my eyes. At each instant, I see the truck and the panel in the same time. But the panel is closer than the truck. So if I see both of them in the same time, it's because truck emits some light before the panel. The truck light and the panel light received by my eyes were not emitted in the same instant, so I see a truck younger than the panel. These differences could appear ridiculous to you, but maybe there is some situations where it could be fundamental. I see images. I see the light that reaches my eyes. I see the past, infinity of pasts. I see a world where nothing belongs to the same world.